Welcome to the latest episode of ASRG World Webinars, bringing you the latest in automotive security research, innovation, and education. My name is Mohammed Mabouli, lead for MEA region for Automotive Security Research Group. Today is the 16th of February, and we are streaming to you live from Cairo, Egypt. First of all, let me quickly introduce myself. As I said, my name is Mohammed Mabouli. I am the lead for MEA of Automotive Security Research Group. I have worked in the automotive industry for the last 15 years, and now my focus is on sales and business development for product and services. I am originally from Cairo, Egypt, but I had worked with different 9 nationalities worldwide. I had managed projects across the world. Some is distributed from 3 locations: Asia, Middle East, and USA. Just quickly, the Automotive Security Research Group is a non-profit organization focusing on the advancement of the automotive security industry. This is a community to support the coming together of 2 areas of competencies. The first one is the IT security market, and the second one is the automotive market. This is a community for you, the automotive engineer, the IT security specialist, the beginner, the hobbyist, even for the people that are in the wrong YouTube channel. This is a community of volunteers. Our entire organization is built on the volunteer efforts of the administrative team and, of course, yourself. We are trying to remove the boundaries that can occur in the automotive security industry. This could be communication, borders, finding ways to learn, finding solutions, making good decisions, because at the end of the day, we all have the same goals: to keep our customers, our families, our friends' data safe and secure, which can be only achieved together. If you want to get more involved, make an impact on the industry, start your own ASRG location, participate in a technical committee, or be a part of a project, please reach out to us. You can find out more about ASRG at www.asrg.io or send us an email at hello@asrg.io. Now, if you look into the numbers, we have more than 6,000 members around the world, 38 locations, and 20 countries. If you would like to start your own location, please feel free to reach out to us at hello@asrg.io. Looking forward to the next webinars we have during the coming weeks. We have the next 5 webinars occurring on different topics, and they are all interesting topics. Please keep following us on different channels, YouTube, LinkedIn, to follow up with our new announcement to attend these interesting topics. So, as you know, ASRG is driving security innovation and making available the resources needed to ensure good security implementation. One of the most important topics during the development of an ECU system or vehicle is understanding which vulnerabilities are existing. So we as developers, testers, hackers, and hobbyists who are members of ASRG can make sure to fix, close, and solve the existing security vulnerabilities before an issue, recall, or even a worse safety issue happens. At ASRG, we thought it was the utmost important to have an open vulnerability management system where we can ensure that the right people have the needed information. We need your support to help to drive the requirements for our next project. Please take the time to fill out a quick survey for the Automotive Security Vulnerability Management Project. You can scan the QR code or copy the link and filling the survey. If you have questions during the presentation, please add them in the chat window and we will ask the presenter at the end. I would like to introduce Gilam, Head of Product Marketing, and Valentina Simeoni, Security Analyst from Cybellum. Hi Guy, hi Valentina. Thank you for being a part of ESRG webinar today.
Thanks, Mohammed, for the introductions. We are really happy to be here and share our experience with the ESRG team members. So, hi everyone. For those of you not familiar with Cybellum, we enable automotive OEMs and their suppliers to develop and maintain secure products. We do so by speeding up and scaling vulnerability management and compliance validation during the development phase, and we enable continuous monitoring and incident response post-production when the vehicles are on the road. In this session, Valentina and I will focus on how to infuse context awareness to your security assessments and leverage that to accelerate vulnerability management. But before we dive into this, I would like to spend a few minutes on the context, pun intended, of this session and the difficulties around vulnerability management. Now, today more than ever, product security teams are facing really tremendous challenges when it comes to performing vulnerability management. There are a number of reasons for that. Automotive software is far more prevalent and complex than it used to be. It's developed using a mix of proprietary and third-party code, be it of open source or commercial nature. And on top of that, there are complexities related to the diverse automotive development ecosystem with its unique operating systems, multiple hardware architectures, file formats, and so on and so forth. And there's obviously the complex supply chain, which means that you don't always know exactly what's inside your software. Now, let's not forget that there are also the risks themselves, be those 0 days or public CVEs. The numbers are constantly on the rise. Just in 2020, we had over 18,000 CVEs published on the NVD. Now, to top it off, we have also the regulation and standards such as WP29 and ISO 21434, which are adopted by the industry and mandate consistent and ongoing vulnerability management throughout the vehicle lifespan, and the institution of a CSMS, a cybersecurity management system, to enable structured and consistent management of cyber risks. As such, and I guess you all know that quite well, product security teams really need to perform at their best in order to meet the growing needs of their organizations and scale their capabilities. Otherwise, they risk missing deadlines, which could impact business outcomes. Now, these are not theoretical challenges. They are very, very real. Just as an example, we've learned from one of our OEM customers that it took them around 5 weeks to properly analyze the impact and fix just a single REPL 20 related CVE. That's a lot of time to spend on just one CVE. And we all know that there are hundreds and maybe even thousands of CVEs that could impact a single automotive component. So what's the solution, you may ask? Well, it's to focus. Focus on what matters the most, the risks that are real. And hopefully do that with a genuine intention to make vehicles more secure, unlike this stillbirth cartoon. In our experience, the way we drive more focus is by better understanding the context in which vehicle components operate and how the conditions of vulnerabilities apply to them. At Cybellum, we get that knowledge and context understanding through cyber digital twins. It's an adaptation of the concept of digital twins, digital replicas of physical devices, that we've applied to cybersecurity research. Through binary analysis, we created detailed representations of ECUs and firmware that reveal the makeup and characteristics of components. That includes the software bill of material, hardware architecture, licenses, operating system, control flow, API calls, and more. But for those of you that don't have such rich representations, you can capture some of that info via various disassembly tools like objdump or command-like utilities like file or strings, in other available tools. Now, once you're armed with this enhanced understanding on how vehicle components operate, you can use it to drive more focus in your work. What we'll discuss now is how to filter out much of the, I would say, irrelevant noise, leaving you to deal with a subset of vulnerabilities that can actually put at risk your vehicle operation. From our own experience, this approach yields dramatic results, as you can see in this example, where 90% of the vulnerabilities potentially affecting a component were filtered out as irrelevant, or may I say rather not impacting, leaving analysts to deal with just over 30 CVEs, out of which only 5 were deemed as critical based on their CVSS score. So this does have a real impact on your work. So we will dive now into a few examples, but just one final point. As I mentioned before, we use binary analysis to understand context. Now, it is especially important in the automotive industry, where source code is not always available for analysis. But even if you do have access to the source code, you would want to leverage binary analysis so you can benefit from post-compilation investigation of the software that captures the full scope, or the real scope of the components being tested. Remember, it's not just about the code you develop, it's how it is going to be used, the operating system, the configuration, and so on. I personally like to compare this to checking the nutritional values of ingredients versus those of a cooked meal. Ultimately, what I want to know is what I'm eating, and when it comes to cooking, I add some spices, maybe some oil. The heat itself alters the properties of the ingredients, so the nutritional values change. So I really want to know at the end how the cooked meal will benefit me or impact me. I hope that simple analogy makes sense to you. Going back to technology, also do remember that in source code, you may have pieces of code that you're not using, and you'll be wasting time and effort if you explore any related vulnerabilities that are not going to be used by your product. So let's see how context awareness is put into good use. Valentina, why don't you walk us through a few examples?
Thanks, Guy. Yeah, sure. So let's dive in and see several test cases that will help us understand the term context-based analysis and how it can help our organization vulnerability management. Now, the first CV is related to the Perl library. Perl before 5.30.3 on 32-bit platforms allows a heap-based buffer overflow because nested regular expression quantifiers have an integer overflow. According to NVD, the severity of this CV is high, which is serious enough for us to try and see if we can filter it somehow. We can see pretty clearly that we already have a hint at the description of this CVE that can give us a clue on whether we should or shouldn't handle this CVE. Now, after a very short investigation, which is way shorter than the time that we would have invested in fixing it, we will find out that the target system needs a sufficient amount of memory to allocate partial expansions of the nested quantifiers prior to the overflow occurring. Therefore, it is very unlikely to affect any kind of 64-bit platforms and systems. But, and there is a but, it requires from you to understand the entire context of your firmware, or at the very least, the CPU architecture. When I investigate CVEs, personally, I use digital twin, but you may get the CPU data using any other public tool and commands like Guy mentioned earlier. Now you can see in this screenshot here that there are no files inside the file system that support 32-bit architecture. This really speeds up the analysis time, and you can eliminate any other CVE that is not matching your CPU architecture. In this case, it's ARM64. This CVE can be filtered without even using any kind of source code or binary analysis. It is just that simple. Now let's move on to the next CVE. Now this is a Linux kernel CVE. This is an interesting CVE because one of the most used attack vectors in the automotive industry is USB. The issue that is described here is a condition bug. This can be caused by malicious USB device in the USB character device driver layer. An attacker who can hot plug at least two devices of this class can cause a use after free situation. Now, we already noticed that there is a hint in the description box. So how can we filter based on that hint? We can check whether the USB ports are enabled or not. In some systems, the USB ports are disabled by running a planned service that runs automatically after every reboot. You can see here the commands that should be included in the service in order for the USB ports to be fully disabled. These commands disable the port's power and do not allow them to wake up from low power states. There are many different CVEs that require support of a certain device type. We can filter these CVEs based on the devices that are enabled on our system.
Okay, so let's move to something a bit more complex.
Now, this is a BusyBox CVE. What is interesting about this CVE? This is actually quite a popular package, and in most of the occasions, it is not compiled with all of its commands. These type of packages draw our attention as potential packages we can try to filter. The issue that is described here is that an out-of-bounds read can be triggered by functions making calls to the DHCP get option function in the UDHCP applet, which can potentially result in disclosure of confidential data in the memory. This is a high severity CVE, so it is brought up to our attention. Now, we have compiled an affected version of this package and a non-affected one, and opened it with Hex Workshop tool. We can see in this screenshot that this package, which is the affected version, has the UDHCP string inside the command section. What it actually means is that all the functions of the UDHCP are compiled inside this binary. However, in this screenshot, we can see that when we opened the non-affected version, UDHCP string was not present in the command section. So basically, when we handle CVEs that are related to BusyBox, or even any other library, we need to check what are the commands and sections of the library that are actually present in our firmware to determine if a certain CVE is affecting our system or not.
Great. So let's move on to a much more elaborate example, and I know that this one is one of your favorites.
Yeah, well, this is a favorite of mine. This is a RPL20 CVE. Now, I'm pretty sure that most of you heard about RPL20 and the shockwave that it brought with it. Some say that COVID-19 was not the only naughty child of 2020. So just to make a long story short, RPL20 is a set of 19 zero days that were discovered by JSOF experts in the Track TCP/IP software library. This is a proprietary TCP/IP stack that has been commonly available for more than 20 years. If you are not familiar with the Track networking stack, it is a software component that provides network connectivity over standard internet protocols such as IPv4, IPv6, ARP, TCP, and UDP. Now, these vulnerabilities have been skulking inside Track TCP/IP stack for at least 10 years and have already been integrated into millions of IoT devices, affecting a wide range of industries, including manufacturing, healthcare, energy markets, governments, and the automotive industry as well. Now, this is a very configurable library. Every instance is different from the other, making it even harder for detection. Like Guy mentioned earlier, it can take weeks until you will even get to the conclusion if a package is integrated inside your system or not. And we already seen cases of customers that didn't even know they were using this vulnerable code. Now, you don't necessarily need to use the Track library to be affected. There are several other aliases for the same package, like ELMIC, GHNet, which is Green Hill Software, Casago, NetPlusOS, KiwiNet, QuadNet, and AMX. So, if you use any of these packages, you are probably at risk. Do note that the successful exploit could impact multiple parties within the software supply chain. Now, in this case, context-based analysis is even more important. Many companies are stressed about these CVEs, and the first step should be to check if these CVEs even match the context of your system, before spending many resources on trying to fix CVEs that may have nothing to do with your firmware. Now let's focus on one of these CVEs. In this CVE, they mention specifically the track library, but obviously it is affecting any other alias. The track TCP/IP stack, before version 6.0.1.66, has an IPv6 out-of-bounds read. Once again, we have a hint right off the start. This is another CVE that demonstrates the importance of binary analysis because you don't know the network configuration from solely checking the source code. Here too, you need to understand the context of your firmware. And if your firmware is not configured to use IPv6 communication and IPv6 packets are not encapsulated within IPv4, then this CVE is not affecting your system. You can see in the screenshot here that the GHNet2 package was detected on a tested firmware. But this CVE is not affecting that firmware. You can see that the given severity is none, and the reason for it is described under the limitation tab. You can see it is only used in IPv6. So just a final note on Ripple 20. We obviously don't have enough time to cover right now all the remaining 18 CVEs, but just in case any of you are patching these CVEs right now, or even just to give another outlook on them. These CVEs have different severities, and most of them are quite serious, but they're far less severe when the kernel architecture is isolated from the application. This separation protects the entire system in cases where the application misbehaves. So you should just keep that in mind.
Great, and this is another juicy one that's related to the Linux kernel this time.
Yes, so this is a Linux kernel CVE. A flaw was found in the NFS version 4 implementation, where when mounting a remote attacker controlled server, it could return specially crafted response, allow for local memory corruption, and possibly privilege escalation. Now, from looking at the description, we see there are no hints or clues. The severity isn't that intriguing either. But there's something very special about Linux kernel configuration. And the method I'm going to show you is very powerful and useful. Okay. So, the Linux kernel has many abstraction layers and levels of indirection. And it built system allows creating highly customized kernel binary images. You can create these customized images using different config symbols, which are different compilation options that can be used to compile the code conditionally in source files and decide which objects to include in the image or its modules. To load the module, the kernel must contain all kernel symbols used in the module. If these symbols were not included in the kernel at the compile time, the module will not be loaded. The kconfig defines each config symbols and its attributes, such as type, description, and dependencies. Kconfig files are actually the files that will determine what features will be included. After parsing these kconfig files, the data is stored in a .config file that stores each config symbol selected value. Then the synconfig takes the .config as an input and outputs many other files like autoconf, autoconf.h, and many other empty header files that are used for configuration dependency tracking. So how can we filter this CVE? This CVE is only affecting if config NFS v4 security label is configured or set to yes. We can filter Linux kernel CVEs by checking the compiled flags and eliminate CVEs that require certain flag that is not compiled inside the firmware. There are more than 2,000 Linux kernel vulnerabilities, so just imagine how time efficient it is to squeeze such a long list of CVEs to the very minimum. Do note it is only relevant in binary analysis, as only after compilation you can truly know what symbols were compiled inside the kernel. In the screenshot here, you can see the kernel configuration file, and the flag for this CVE is set to yes. So if we will compile this specific Linux kernel, then this image will be affected.
Great. So this following one is actually very relevant for the automotive industry because it relates to the BlackBerry QNX operating system.
Yeah, so this is a very popular, indeed, open source library in our field. Now, the issue that is described here is that an assertion failure can occur when specially crafted query for zone signed with an RSA key. To be vulnerable, the system must be running bind that was built with enable native PKCS11 string. Now, the highest threat from this specific vulnerability is to the system availability. Once again, we have a hint right off the start. This is a high severity CVE, which already makes me intrigued. So let's see where the hint takes us now. Let's start with checking what actually happens when we compile the library with enable native PKCS11 string. From looking at the attached configure.ac file, it seems as it puts the PKCS11 string inside a crypto variable, and if the crypto variable is initialized with PKCS11 string, the code is compiled with the actual flag use PKCS11. So we actually get a new flag, which is our next hint. Let's see how this flag is compiled. We can see that this flag is compiled with several strings marked with rectangles. So if this flag use PKCS11 will be compiled, we should expect to see the strings inside the compiled file. And if the following strings will be absent from the binary files of the firmware, then our firmware is not affected by this CVE. What's interesting is that this specific case involved both source code analysis and binary analysis. But binary analysis is the final step in the process that can 100% determine if you are affected or not.
Great. So let's move on to the final example that we have, which is actually related to a very popular package that we encounter.
Okay, so this is a Sqlite Cve. This is another intriguing high-severity CVE. When FTS3 extension is enabled, encounters an integer overflow for FTS3 queries in a merge operation that occurs after crafted changes to FTS3 shadow tables, allowing remote attackers to execute arbitrary code by leveraging the ability to run arbitrary SQL statements. Now, what is interesting is that a lot of Sqlite CVEs are actually connected to a specific Sqlite extensions and plugins that are not compiled by default. Now let's once again, like with bind, start with investigating the source code. We can see that this library is compiled with Sqlite enable FTS3 when the FTS3 extension is enabled. When searching for files in the source code that are related to this flag, we come across the next interesting file, which is the ctime.c file. This is an important file since it reports what compile time options the Sqlite library was built with. From looking on the makefile.ini, we can see that the ctime.c file is always compiled. So basically, we can always rely on this file. So how can we filter it? We can use the information inside this file to see what extensions were compiled inside this library. When searching the ctime.c file, we can see that the Sqlite enable FTS3 flag is always compiled with enable FTS3 string. So if this string is absent from our compiled file, we can in fact know that we are not affected by this vulnerability.
Great, thanks, Valentina. These were really great examples. Just to wrap it up, a few words to summarize. The job of the product security team is not going to get easy. There's lots of complex code out there. Many more threats and regulations and standards are put in place to drive structured processes that will help you manage risk. For security teams to do their job well and fast, they need to make sure they keep their arsenal fresh and relevant. And binary analysis is an important capability they should leverage.
As we demonstrated, context awareness saves time. There is an endless list of options we can filter our CVEs by them. In this session, you all got a small glimpse into the world of context-based analysis. We showed you that it is possible to filter CVEs based on their CPU architecture. And we only shown you one example. But there are a lot of more CVEs that can be filtered based on maybe 64-bit platforms. I know, in fact, that some of them are even to 2021 CVEs, fresh from the oven. You can also filter CVEs based on their operating system. It is important, especially in our industry, since there is a very long list of CVEs that are only affecting Windows. And we can simply ignore this list. We can detect these CVEs usually very easily by reading really carefully the description and look for mentions of DLLs or even the C driver. Another way we can filter our CVEs is related to the fact that sometimes we only use a certain part of a specific library, when we only need one module or a very particular functionality. And then there's sometimes CVEs that are related to a certain file that is not compiled maybe into our firmware. On the same level, you can also filter CVEs that have based on certain commands and functions that are missing from the library, like we showed you in BusyBox and Linux kernel. Another concept is that there are cases where we use certain packages that must be compiled with its dependencies to be functional. If these dependencies are not present in our firmware, well, again, this is irrelevant to us. There are a lot more ways we can filter our CVEs, but these were the main ones.
Thanks, Valentina. This wraps up our session. We'll be happy to take any questions you may have. But just before we wrap it up, we just wanted to remind you also of the survey that ASRG is running about vulnerability management today and tomorrow. So we are urging all of you product security experts to either click on the link or scan the code there and make an impact. Thank you very much.
Thank you.
Thank you, Guy and Valentina. We already have a couple of questions to you. So the first two questions are already coupled to each other. The people are asking about the static analysis tool, how it is different from the context-based analysis that you are presenting. So that's the first question.
So the aim is to know if you have to actually deal and handle all of the CVEs by upgrading all of the software that's connected to it. By analyzing what's actually relevant, you can filter a large percentage of the identified CVEs in your component.
So the second question is, can we do a lot of checks with the static analysis tools instead of going to doing the context-based analysis?
Yeah, I think it's basically the same response. I mean, yes, you can.
Okay, so the third question from the same person is regarding the Linux and Rich OS application-based, like what we can see in the automotive industry. So what about RTOS-based ECUs, which are written like with AutoZAR or OSIC-based? Does this technique can cover also the same vulnerabilities?
Well, in real-time operating systems, for example, you could have the track TCP/IP variant compiled into the firmware, which have the RIPL20 CVEs. So you could also handle them because of most of the RIPL20 CVEs that affect track are not useful because most of them are connected to specific modules inside the track TCP/IP stack that are not complied into the firmware.
So another question is related also to the OS. You had been presenting a lot of OS that are having a lot of vulnerabilities. Do you think there is one OS in the market now which is having the less vulnerability that can be used in the automotive industry more?
I'm not sure I have that statistic. I think we're seeing lots of vulnerabilities everywhere in Linux, and as we mentioned earlier, in Unix, there are many variants of Linux. I'm not sure I have currently a favorite one I can recommend off the top of my head.
Okay, so another couple of questions we have also. The first one is regarding the binary analysis. So people are asking if you have your own tools that is used for the binary analysis, or you use open source tools like Hydra, or do you use some property tools like IDA Pro?
Yes, there are various tools out there in the market. We have our own proprietary platform that does that. I hope that answers the question.
Okay, so the last question we have till now is regarding the sources that you evaluate considering the CVEs. Any sources people can use to consider while they are evaluating the different CVEs?
We try to evaluate whatever we can, the configuration that's connected to the CVEs, the exact code that's connected to it, and so on and so forth.
Another question is regarding is the presented CVEs are the only available, or what we can see on the iceberg, on the top of the iceberg, or there is a lot that we still need to evaluate to find out?
Oh no, these are just examples that we thought are interesting to share with the SRG team members because they're very varied and show different ways of doing filtering and so on and so forth. We are not saying that these are the most popular one or the ones that we see the most. We just saw them quite a few times, but I wouldn't say that they are the top ranking. The RIPL20 is definitely popular, but it's just good example. We thought it would be good learning experience for everyone. Any other questions? Okay, so I guess it's a wrap up from our end. Thank you very much for the opportunity to present and share our knowledge. And if you have any other questions, you're more than welcome to reach out to Valentina and myself after this webinar. We'll be happy to take additional questions.